we are asked to evaluate this sum given in sigma notation using the properties of sigma notation. Now over here I have copied two useful formulae that we're going to need so that we can refer to those as we do this. If you're not sure where these come from, then look back at the previous section of notes. Now, evaluating this, the first thing we need to do is to split it up. So the first thing we're going to do is split the sum into three sums. We're going to split it into the sum of k squared from 1 up to 20. We're going to split it into minus the sum of 3k from 1 up to 20. And we're going to add on to that the sum of 2 from 1 up to 20. And then this one we're going to factorize. The other two we're not going to do anything else with it just now. So k squared minus, we're going to factorize out that 3. And we're going to get that result there. And if you need to see how or why we can do that, you can go back to the previous section of notes. And then we leave that one as it is. Now this sum is this one here, but with k instead of I. So we're just going to replace n with 20. So it's 20 times 21 times 2 times 20 plus 1, so that's 41, all over 6, minus 3. And then this one, the sum of k, is this one, where we're using k instead of I as our dummy variable. So it's going to be 20 times 21 over 2. And then this one is just adding 2 together 20 times, so it's 20 times by 2. Now each of these are relatively, well these first two anyway, are relatively large multiplications, but certainly doable. For this one we get 2,870. For this one we get 630. And for this one we obviously get 40. And combining those we get a final answer of 2,280. This certainly has fewer steps in it than working out this term for 1, 2, 3, 4 all the way up to 20 and then adding all those things together. It does involve a larger multiplication, whereas doing it this way you don't have to do that, but you would have to square all the numbers from 1 up to 20. It saves us a little bit of time, and most importantly it's about understanding how the rules of the properties of sigma notation work.